Hi everyone, this is a series about me making a model of A-star algorithm in Godot 4. So far I've got manual pathfinding done. For those who don't know what A-star is, it's a pathfinding algorithm which uses three values to represent how likely a position is to be a part of the desired path. Those being g-cost, value representing how long it took to get to a position, h-cost, simply how far away the goal is from the node, and f-cost, which is the sum of these two values. A-star algorithm calculates the cost of every position it checks and processes the one with the lowest f-cost. This way less positions are checked and pathfinding is a lot quicker. I didn't actually get to creating an automatic pathfinder, as you can see, an automatic pathfinder. And instead of positions in space, I use these nodes, which are little squares in a tile map, or tiles. And I'm actually using a tile map layer to change the color of each node. So here we can see our start node. If I restart this, it's green. And then when I click it, it changes the color of itself and the nodes around it. Green nodes are the check nodes and the purple nodes are the process nodes. So here you can see the F cost, H cost, and we are supposed to click on the node with the lowest F cost because that's how the algorithm would work. So this is 70, this is the lowest F cost, and this is also 70, and this is 70, this, up until the very end where it changes, and this doesn't matter simply because the path is formed. This can be seen on any straight line with this algorithm, simply because when the G cost increases by 10, which is the width of one tile, by the way, I made it so that cost is calculated uh, with 10 being the width of a tile, and since the script calculates it diagonally, it's around 14 to 15, but in a straight line it's always 10, and when the G cost increases by 10, the H cost decreases by 10, so they balance out and give a constant F cost in a straight line. Let's see how it works with a bigger tile map. So here I have a slightly bigger tile map. It's not actually bigger, I just have the start node and the end node further away, and you can see the values got a lot bigger. This is just because the H cost got bigger, like you can see here, because they're further, yeah. And I'll speed it up for you, but we basically do the same thing. We click the nodes with the lowest F cost and give highest priority out of those with the lowest H cost, or the ones being closest to the end node. And here's our path. When we got to the end node, uh, it just checked every single last node I visited, and it just goes, iterates through all the last nodes until it gets to the start node. How it works is I actually set the last node I visited when I set the costs for each node. For example, when I click the start node, uh, the last node for every single green node you can see here is the start node right over there, and it just checks the last nodes until it gets to the start point. There's also something I want to showcase. For example, if we do this, for example, there was an obstacle, and then we find out we can actually go around that obstacle another way, and look at this value over here right now. It might change. Here it is, it became a lot lower. We cannot do this with process nodes, but with checked nodes, they might change their values if we've found a more optimal path. I'm just checking which path is more optimal, and it changes its last node as well. So if I build a path right here, it now goes there and not over there. And as you can see, this node was also not counted because when I get stepped on this node, the last node for this stayed this node because it's more optimal to go like this than it is to make corners. But the purpose of a star algorithm isn't just to find straight paths. To make one object go toward another object is actually quite easy. You just subtract their positions and normalize the vector, and you get a direction which you can apply the speed to. And this is basically how it's done. It's very easy. But what an A-star algorithm does is it provides a way to overcome obstacles which you could not overcome if you were traveling in a straight path. So right there we're having a big black obstacle and we cannot actually go through. Like here I check our start node, and if I go right there it just doesn't check. I cannot make path over here. So let's use our A-star pathfinding, and I'll speed it up for you so that you can see it visually. So as you can see here, when I process the end node, I've actually found the path quite quickly. I just had to check a lot of nodes before that obstacle because A-star algorithm just tries to go through the obstacle and just processes the nodes around the start node because they have low G cost. But you can see that it never goes too far behind. Actually, it never went anywhere further than the nodes we searched initially. Further behind, I mean. And it was pretty efficient, I think. So I could play around with that, and I hope I can update it to automatically find the path by itself, like I already have the function pathfind right there. It's supposed to search through the lowest F cost node in open, which is check nodes, and then the lowest H cost and the minimum F cost nodes, and then it like processes those. And pathfind is supposed to be in set nearby nodes, I think, or in set node. Anyway, how I do this is I just set custom data to black tiles to be the obstacles, like you can see in the paint tab here that they're marked as obstacles, and the code does not register them, and so just kind of finds its way through. And besides that, I don't think that there could be many variations. I think my code is pretty simple, and here in the manual set function, set is where I set nodes, by the way. it checks for input of a left mouse click, and it sets the node to be node with position of the mouse like cursor in the in ready the init pathfinding is called, and it basically initializes all the stuff that needs to be done before pathfinding ever happens, and there I create nodes on each and every tile in specific range, which in my case is 9.5. It's right there. Like if I select tile map, you can see 9.5 in this corner. And basically it creates nodes on every single tile, and then just checks for the position of the node and appends data on the node that was created beforehand. It's simpler than it sounds, probably. I also use a lot of -1s to like indicate the fact that G cost has not been set or H cost has not been set, and right there you can also see a lot of cents, which are basically required for better precision, since like right there, if not for a timestamp, this would be 14, this would be 14, this would be like this would be 13, 13, and 13. How am I supposed to understand which one is the best? It's not that big of a deal usually, but in this case, I just want it to be this precise. It's how it's usually done. So, if any major updates will be coming up, I'll release a new video. Hope if you've got any tips for me, you say your feedback in the comments, and yeah, I think this needs a lot of improvement. I would really appreciate your help. Thank you.